Students, you have seen the limitations of Bohr model. Many limitations are there in Bohr model. So, to explain all the properties of atoms, a new model was to be found out. By the time certain developments were helpful in formulation of the new model of atom, which is known as quantum mechanical model. Before moving on to quantum mechanical model, we'll just check what are the developments that led to the model of atom. First one is dual nature of matter, and the consequence of that is explained as Heisenberg's uncertainty principle. The developments which paved the formulation of quantum mechanical model are dual nature of matter and Heisenberg's uncertainty principle. First one, dual nature of matter. Dual nature of matter was proposed by the scientist de Broglie in the year 1924. He suggested that matter consists of dual nature. He proposed that just like light, all matter should possess both particle and wave nature. You know, dual means two. Two types of behavior are shown by matter. It shows the property of particles as well as waves. De Broglie incorporated the particle behavior and wave nature of matter and derived an expression to find out the dual nature of matter. We'll see it in steps. First one, particle nature was proposed by the scientist Einstein. Einstein's mass relativistic equation explains the particle nature of matter. That is, E is equal to mc square, where E stands for the energy of the particle, m stands for its mass, and c is the speed with which the particle is moving. That is the speed of light, 3 into 10 raised to 8 meter per second. So this is Einstein's mass relativistic equation. He also suggested that matter will have wave nature, and that was proposed by the scientist named Max Planck in his equation E is equal to h nu, where energy is believed to move as discontinuous packets of energy, each packet known as a quantum, and it is given by the expression E is equal to h nu, where E stands for the energy, h is the Planck's constant, nu is the frequency of the radiation. So E is equal to h nu is given as the Planck's equation. Both represents energy and it can be equated according to de Broglie. So we have the expression mc square is equal to h nu. But we know nu is c by lambda. On substituting, we get c by lambda is equal to mc square, which can be simplified, and we get the equation lambda is equal to h by mc, cancelling out c and c from here. So then, this expression is explaining the behavior of a particle with mass m moving with the speed of light. Here, Lambda represents the wave nature of the particle, whereas m into the velocity, that is the momentum, represents the particle nature of that substance. So, this equation connects wave nature with that of particle nature. Suppose the velocity of the particle is given as v, we can have the equation lambda is equal to h by mv. We know that mass into velocity is called momentum, and that is represented by the letter P. So we have the equation h by P is equal to lambda. This is called the de Broglie equation, which denotes the dual nature of matter. And electrons are also matter. Electrons can show also have dual character, that is it has the wave nature as well as the particle nature. So the equation connecting wave nature and particle nature of electron is given by the de Broglie equation, lambda is equal to h by p. We know that kinetic energy is given by half mv square. So from this equation we can calculate the velocity as equal to root of 2e divided by m. But we know that lambda is h by mv according to de Broglie equation. So on substituting the value of v in the equation here, we get h by m into root of 2e divided by m can be calculated as h by root of 2me. So, from the expression, we can understand that if the kinetic energy is known and if the mass of the electron is known, we are able to find out the wavelength of the electron. Here, h has the value 6.626 into 10 power minus 34 joules second. This is known as the Planck's constant. We shall now see the significance of de Broglie relationship. De Broglie relation is not significant for macroscopic objects, but for microscopic objects like electrons moving with a mass of m and wavelength, it is always measurable. So, de Broglie equation holds good for microscopic particles. Next is Heisenberg's uncertainty principle. Heisenberg in the year 1927 explained that the position and momentum of microscopic moving particles like electrons cannot be determined simultaneously with accuracy or certainty. If x denotes the position of the particle, delta x denotes the uncertainty in position, and if p is the momentum, delta p represents the change in momentum or uncertainty in momentum. What he said is that it is difficult to simultaneously determine the position and momentum of a microscopic particle. So, the mathematical expression is delta x into delta p is always greater than or equal to h by 4 pi. What does it signify? Here you find that h is a small value, 6.626 into 10 power minus 34. So if you divide it by 4 pi, we know the value of pi to be equal to 22 by 7. So then the value still becomes very small. That means if you try to position the electron, it is difficult to find the momentum. But one, if is concentrating only on the momentum of the particle, then we can't locate the electron. So this helped in explaining the new model of atom, where there is no certainty in finding out the electron around the nucleus, and that led to the new model of atom, which is known as quantum mechanical model. Heisenberg's uncertainty principle is the direct consequence of dual nature of matter. Dual nature says that electrons have both the behavior of particles as well as waves. If the electron was possessing only particle nature, it is definite to find out the location of the particle around the nucleus. But here we have seen that the electrons are possessing two types of behavior. So to locate such a small particle around the nucleus, it becomes difficult. If we try to locate the particle, the momentum becomes out of control. Whereas if we are trying to find out what is the speed of the particle, then we are unable to locate the particle. So this is what is meant by Heisenberg's uncertainty principle. Heisenberg's uncertainty principle states that it is difficult to simultaneously determine the position and momentum or velocity of a microscopic particle. We know that momentum is mass into velocity. So the above equation can be rewritten as delta x into delta of mv greater than or equal to h by 4 pi. So then delta x into mass into delta v greater than or equal to h by 4 pi. The reason is mass will never change for a particle. That is why delta x into m delta v greater than or equal to h by 4 pi. Just now we have seen two expressions to express Heisenberg's uncertainty principle. So, the new model of atom called the quantum mechanical model was established with the help of dual nature of matter and Heisenberg's uncertainty principle. Quantum mechanics is the branch of science that take into account the dual nature of matter, like that of electrons. Quantum mechanics was developed independently in the year 1926 by Werner Heisenberg and Erwin Schrödinger. In the year 1926, the basic equation for quantum mechanics is given by the Schrödinger equation, which is given by h cap psi is equal to E psi, where h cap is known as the Hamiltonian operator. Just like how we have addition, subtraction, division, multiplication in mathematics, in higher mathematics and higher physics, we have the new operator which operates on certain functions called wave functions, which is represented by the letter psi, and this wave function is operated by the Hamiltonian operator h cap. And the solution of that will help you to understand the space around the nucleus where there is a chance or probability of finding an electron. And such a space was later termed as orbital. Remember that in Bohr's model, we have explained that the definite pathways around which the electrons are moving around the nucleus, that was called as orbits. Unlike that, these are just region around the nucleus where there is a chance of finding the electron. So this is a three-dimensional region where there is a chance of finding an electron. Definite location of an electron is never possible for microscopic particles. This is explained by Heisenberg. Only the basic equation of quantum mechanics is dealt with here. We are concerned with only the solution of the quantum mechanics equation or the Schrodinger equation. Solution of Schrodinger equation is actually dealing with the dual nature of matter.